Hey, so my name is Chris. I work for Twitter. And so this year I thought I'll do something different. And I was a little worried because I'm doing basically everything's live demos more or less. And the Wi-Fi didn't really work, so I was a little worried about it. But we got it working. So I work for Twitter. Twitter has a small VM team. It consists like of 4 people, and then we have another guy working on machine learning stuff. If you're going to tweet about this talk, it would be nice if you add that hashtag so that my other team colleagues know what's going on here at FOSDEM. So in general, why am I doing these talks? You know, you might have seen a talk of mine before, and they're always about Graal stuff and how we do things. I don't know if you've seen my previous talk where I talk about that we use Graal at Twitter in production, so it actually works and stuff. So you can watch that on YouTube if you want. The main purpose of my talks is always to get people to try it. Like Christine just said, try your GCs. I say try your compilers. So at Twitter, we save money by using Graal. I cannot tell you how much money, but it's substantial. It's way more than I get paid. So yeah, I don't know if that's good or not. So you can also save money. Yeah, right, exactly. So that's one good reason, or something you can approach your manager and say, hey, we might be able to save some money. So you have to try it. The other thing is that I want to fix all the bugs that are there, right? That's also very selfish because if you guys find a bug and you fix that bug, we at Twitter, we don't hit it, and Twitter stays up. So that would be good. And then lastly, also to improve Graal, right? There's still a lot of stuff we can improve on. And it's a little easier to work with than C2, so it's actually easier to do improvements. And then people come to me after my talks and say, well, is it safe to use, or does my data center burn down if I run Graal? So our data centers are still fine. And since, I don't know, June last year or something, we are running our main Twitter services. So basically everything, when you tweet or when you retweet, everything, 100% of that stuff is running on crawling production today since last June or something. So it's fine. Then people ask me, how do I use it? Where do I get it? Sometimes I get emails later, and people have been trying it, and they mostly complain about the benchmark numbers, and they usually say, well, it really sucks. That's because they don't really understand that Graal is different than the existing compilers. And so this talk is to explain this. So what is Graal? Just briefly, it's a Java virtual machine, just-in-time compiler. It takes Java bytecode and translates into native code. Actively developed by Oracle Labs. John Rose was talking about it earlier a little bit, so I don't go too much into detail. These are the links where you can read up on it. It uses JVM JIT, and it's written in Java. And that's very important to remember throughout the whole talk. It's written in Java, so it has all the properties that Java programs have, right? It uses Java heap memory. It loads classes, all this stuff. So remember this. Where do I get it? The answer, as always, is it depends, unfortunately. But this will change pretty soon with JDK 10. This will change. But where do I get it? So there is chap 295, which is the ahead of time compilation chap. And this one, when you go to this chap, you see, oh yeah, it's in release 9, and it's delivered, so right, because 9's out. When you scroll all the way down, you see the dependencies, and it says, it depends on JVM CI, and then it uses Graal and so on, and the project will merge Graal core into the and it delivers it.
It works.
I don't know. Cool, yeah.
Just
Magic.
relaxing.
And delivered in Linux x64 builds. And so that's the depends. So if you're running on Linux x64, you can take JDK 9 and you have Graal automatically. if you're not on Linux x64, then you have to either build it yourself, or you can download a JDK 10 early access build, and then you get it. There's this one bug here that adds support for, basically the reason why it's not in 9 is because we couldn't write the native shared libraries for the AOT feature. That's what kind of the reason. Okay, so what do you need is a JDK with JVM JIT, JEP 243, and with AOT, because that gives you Graal for free, basically. And that's on Linux, that's greater equal than JDK 9, or Mac, Windows, greater equal than 10. And you can download it from here, and we're not doing that now. So the way I do this talk usually is I use an Oracle Cloud container, and I start that container up, like on the fly. And I'm doing this to show you when people when I go to conferences and I see talks where people do live demos, I always wonder how many hours did they spend to prepare the container or the machine that actually everything worked, right? The demos and stuff. So, but I decided I fire up like a cloud container with no setup at all and do all the demos and show you that really all you need is download all the JDK and so on. But since it's only 25 minutes, I can't do this, so you have to trust me on this one. I'm just showing you. So I started one up. I'm part of the Oracle Developers Champions program, and so they give me free access to cloud time. It's like a budget, and then I can use it. That's really nice. So that's what I'm using. So I have a machine in Frankfurt, as you can see here. And everything's so small that I don't even know how to get there. All right, usually I don't know how to get there now. There's more up here where you can see, I don't know. Yes. Instances, that's what I want. Thank you. So I have a running FOSDEM instance, and it has a public IP address, this one. So we just log into this guy, right? And the second time. And so I've already downloaded all the stuff that I need, and we have the JDK 9. That's the open JDK 9 build you can get from Java. Whatever it's called, the link I had earlier. So just download that one, and we are setting just Java home here to this directory. And then we are also putting it on the path, and I've done this before, so I can shortcut a little bit. And then we have this Java version. And over here, we are doing the same thing. We are comparing C2 and Graal. That's why I have two windows here. So we're doing a Java home again, this guy, and the path. And then in this instance, oh yeah, I'm also using this environment variable called Java tool options. And I use parallel GC because it's a little easier later to not look at G1 output. It's easier to look at parallel output. And we do a 512 meg heap and maximum and start. And there you go. And the same over here. Wait, no, let me go back. So usually I start up this container and it takes a while and then I talk about myself. So the only thing I'm saying here is because Charlie called me out. I'm the Lava 1 organizer, so if you guys want to come to Hawaii next January, So the rest I skip. So back to the demo. What you can do in JDK 9 is you list all the modules. It's like, I don't know, like 75 modules or something like this. And then, as we've seen before, the AOT chip depends on JVM JIT and Graal, basically. And then you can say, okay, Java, what's it called? Describe module, right? So we want to describe the JDK AOT module. And this, no, that's not right. Describe. Here we go. So this is the JDK AOT module, and it requires jdk.internal.vm.ci, that's JVM CI. And it also requires this guy here, and that's Graal. This module contains the Graal source code. So if you have these two, these two, you don't need AHU really, but if you have these modules in your JDK 9, then you're good to go. Okay, that's all you need. So get a JDK with JVM CI and AOT, yes, checkmark, we just verified that we have that. And then the only thing you really have to do is to turn it on. That's all. So how do I use it? So let's go back to our chaps here. And then if we go to chap 243 here, you can see when you scroll down a little bit, oh, look, this is how you turn it on. So all you have to do is take this. So since these are experimental options, you have to unlock them, and then you say, oh, I want to enable JVM CI, which not automatically turns on the compiler, it just enables the Java interface, and you could then use something like Truffle to schedule compilations. But what we really want is to replace C2 with a JVM CI compiler. In our case, that's Graal. Okay, so we take that and we stick it into our Java tools options, like I have it somewhere here already. All right, we just changed that to 512 here real quick. And as you can see, unlock, enable, use JVM CI compiler, okay? So if we do something like this, then we see, oh yeah, the options are being picked up, but there's no real difference, right? Nothing's really happening, okay. Then let me quickly go back, yes. There is, so we have now JVM CI enabled, and then you can do print flags final version, and we grab for JVM CI. Okay, here we go. These are all the JVM CI options that we have. So for example, yeah, we enable it, and that's true. The one I'm looking for is the JVM CI print properties. So this guy. Okay, here we go. That's a long list. Let me make it a little wider here. That's a really long list. So there are a few JVM CI properties. So since JVM CI is written in Java mostly, and Graal is written in Java, command line options are being passed as Java properties. So -D and then, whatever. So there are a few JVM CI properties, and then there are a bunch of Graal, right? So the one we are looking for is this one here, which tells us a little bit about when JVM CI starts up, okay? So we do this, and we say D, timer, we have to say true because we turn it on. And so we do a dash version, and we see nothing's really happening, so what the hell is going on? So the way it works is we are running tiered, right? And if we do a print compilation here, wait, let me do that again. You see this column here is the level of compilation, the tier level. And tier 4 would be C2 or Graal. And everything we compiled so far, because a dash version doesn't do a lot, we're not actually doing a level 4 compilation. And so JVM CI will never be initialized because it's lazily initialized. So we have to do a little bit more. We can run the couple, for example, and do it a dash L. So we can see, okay, something's being initialized, and it's called hotspot JVM CI runtime. That's a class. But it seems like that's only it, and it's not really finishing it. And the reason is the initialization of JVM CI and Graal would take too long. So the program actually exits before all the initialization is done. So we have to run a little bit more. So we do a small run of Aurora. And then see, oh yeah, that looks much better. So we initialized JVM CI. There's an implementation of JVM CI runtime called hotspot JVM CI runtime, right? That could be technically a J9 JVM CI runtime, just throwing it out there. And then we initialize something called a hotspot Graal runtime. And that's really the compiler. You see, we initialize all these providers, and then we create the backend for our CPU, and so on and so on. And then we run the benchmark, okay? So now we are really using it. Good. Well, let's go back to the slides. And I have 10 minutes, okay. Usually a demo takes 5, so maybe I can do 2 more. Bootstrapping is, you have to remember, it's written in Java, right? So Graal is just another Java application that's running in your JVM. So if you want to run it, it will get compiled as any other Java code you have running in your VM, okay? So it loads Java classes because it's written in Java. It has Java methods, obviously. And these, at some point, when your compiler, when Graal starts to compiling your application, these methods get hot as well, and they need to be compiled. That's called the bootstrap, okay? So let me do a quick bootstrap demo. You can turn this on explicitly, and you'd say, oh, bootstrap my JVM CI, okay? This cloud instance, by the way, has, I think, 4 cores, so 8 threads, something like this. And it uses a bootstrap. It uses all the threads it can get and bootstraps it. So what a bootstrap really does, it takes all the Java lang object methods, which are super simple, right, and schedules them for compilation. And then because you're compiling these small methods, the whole compiler gets warm and compiles itself. That's what the bootstrap does. So it takes 10 seconds to compile 2,500 methods, which is quite a bit, right? So that's something where people are saying, well, you know, I don't want to wait 10 seconds every time I start something. But you don't have to explicitly bootstrap it. You can also bootstrap it basically automatically while you go, okay? So when you, for example, let's do a print compilation here. Oops. A print compilation of, yeah, let's run that same benchmark again, why not? And we grep for org Graal VM. Okay, here we go. So here we see that we didn't do an explicit bootstrap. This is just being implicitly done while we go along, right? And you see, oh, it's being compiled, and the benchmark's done, and some methods are still being compiled. But what's important here is you can see the compilationist level is always 1. And there is a flag in Graal. It's called, wait a minute, what it's called? JVM CI, I want this guy. Print properties, right? And we grep for C1 only. Here we go. So there's a property called compile Graal with C1 only, and that's by default true. And the reason this is set up that way is C1 throughput is much, much faster than let's say C2 or Graal itself, right? So we want the Graal itself to be compiled as quickly as possible and not take as much CPU away from our application compilations or even the application itself. So we just compile with C1, and that's usually fine. Yes? I can, and if I had 50 minutes, I would show you how to do it, but apparently we don't. So yes, you can. Next year. The other half of the talk will be next year. Okay? So this is what a bootstrap is and how bootstrap works. We could also turn off. You know, if we go here and say, okay, dash capital D, and this guy, and then we say false. Then we'll see, oh, there are a bunch of 1 compilations in there and then 3, and so at the end, we'll get to level 4 compilations like here. So if you turn it off, you go through the whole tiered system, and Graal will compile itself. Takes much longer, obviously, but I have 6 minutes left. I can, yeah, well, I'll show it to you. Why not? So we do the bootstrap, and we say, okay, we do false here. Oh, wait. No, I'm not doing this. I have to show you something else. This is important, and I'm still debating if I should file a bug for this or not. Because when you do a bootstrap, an explicit bootstrap, it's actually ignoring the compile Graal with C1 only flag. So it's compiling it with itself every time you do an explicit bootstrap. So I think that's very important. And I don't know if it should do it, actually. I think it should honor the flag. And if you tell it, hey, only compile with C1, just compile with C1. I should mention sometimes an explicit bootstrap might help, even if it's upfront time that you're just wasting and waiting on. But C1's not optimizing as well as C2 or Graal does, right? So C1 doesn't have escape analysis, for example. So all the allocations that will be done in Graal, the compiler will then go to the Java heap. Nothing will be escape analyzed or scalarized or anything. So if you're expecting that later in your application run, you're still compiling a lot and you want these compilations to be quick, a bootstrap or turning off the C1 only flag might be better. Okay, so going back to the slides. So that was the bootstrap demo. What did we learn? Well, the bootstrap compiles about 2,500 methods. I didn't do the non-tiered one, but it compiles even more because then more of Graal gets hot and it just compiles more of itself. So you can do it either upfront or on demand during runtime. I would suggest to you to not touch the bootstrap flags and just let it run. If I could do the production demo that I have, you would see that it really doesn't matter. And then by default, we compile only with C1 and bootstrap. The explicit one does it slightly different. So Java heap usage. Graal is, exactly, it's written in Java. So if Graal compiles a method, it uses Java heap memory to do that. Depending on the C1 only flag that you're using, if you set that to false, all the Graal methods itself will use Java heap memory. That's very important because usually, we at Twitter, we do the same, right? You tune your heap to exactly like how much you need, maybe a megabyte of free memory, but then suddenly a compilation can kick in, a big one, and that can take up 100 or 200 megabyte of memory. So let's do a quick 3-minute Java heap demo. And so we're actually doing something over here as well. What I want to do is, yes, no, it's still all right. So we log GC, and we run, I think we run that one again. So we do that, okay, and then we see, I'm using this benchmark because it's very computationally intense, and it's not really doing a lot of allocation and GC stuff. So it runs like 10 seconds, right? And there is no GC happening during the benchmark run. It's just the da capo benchmark harness does these GCs explicitly. So if we do the same over here, we'll see there's a little bit more going on, right? And that's exactly what I'm talking about. So we are compiling the Aurora benchmark itself, and while we are compiling it, Graal is using Java heap memory for that. So you have to be aware of this. The two things, oh yeah, one thing I haven't shown you yet, I want to show you that too, I still have time. So there's something called CI time. It's a really badly named option because what that means is the compiler interface time. That's not actually true. What it really measures is the compile broker time. So how much time does it take to compile methods and how many methods does it compile? So let's do that over here too. CI time. And as we can see, so we compile about 1,000 methods with C1 and about 300 with C2. Don't pay too much attention at the time and especially the bytes down here when we look at the JVM CI numbers, because this number contains inline bytes while the JVM CI one doesn't, and it's just the way because it's C++ code and it's hard to get that value back into the VM. So just believe me, it's really not that important. So we compiled about 1,000 here, and here we compiled 6,000, okay? And that's all the Graal stuff, right? You remember the implicit bootstrap is compiling just with C1, so we're compiling roughly 5,000 additional methods. They're not all Graal methods because there are also core library methods involved. Because Graal is written in Java, it uses a bunch more of the core library, so core library methods get compiled as well. And we compile 400 with JVM CI, which I'm not exactly sure why we do that. It's 100 more, and I also think it's, we'll have to look at the compilation output, but I think it's also core library methods. Because the Graal ones are only compiled with C1, but if something, because of Graal, gets hot in the core library, it will still get compiled with tier 4. Okay, does that make sense? I hope it does. And I'm out of time. Yeah. That's the last thing I'm saying. So Java uses, Graal uses Java heap memory. That will change at some point. But today we don't have heap isolation. And keep in mind something that Christine also said. It's important how much memory JVM uses, because C2 also uses that 100 or 200 megabytes to compile a method. It's just not as visible because it's not on the Java heap. All right, thank you.